So in the third set of notes for 9A, we're going to look at a couple of word problems that use exponential functions. We're going to be given formulas that we're going to use. Now I'm going to flip back to that second page here where I've got these two basic graphs. This first graph is called a growth function, and the word problems that are going to use this particular exponential function, the money, like in the first example, we're going to talk about the money that we invest grows exponentially. And the second example, we'll be looking at a decay problem. So we'll have a certain amount of something, and the amount that exists will slowly decrease in that situation. So here we have here the exponential function a is equal to p 1 plus r over n raised to the nt power models. It's actually the compound interest formula, but it models the dollars a which are accrued or owed after p dollars are invested or loaned at an annual interest rate r compounded n times each year for t years. So here I've kind of got this. This is what we start with. The P, or the principal, is what we begin with, and it's going to increase over time. And then the A is the end amount at whatever time we're talking about. All right, so let's look at this problem. It says find the amount owed at the end of 5 years. So notice that the 5 then is going to be the number of years. So this is our T, the number of years. If $1,600 is loaned, so this is then going to be, this is what we're starting with, the amount we're starting with, so that's our P, at a rate of 9%. So 9% is the R, the interest rate. So we're going to then use 0.09 for our R. So I'll just put that right there. And it's compounded monthly, which means it's compounded 12 times a year. So that's going to be our 12 was our N. So N is equal to 12. All right, so now let's use our formula and put that in. So we're going to end up, we're going to find the amount that's owed. So we're going to look for A. That's equal to P. So our P was $1,600. Then parentheses 1 plus R, which we changed to a decimal, 0.09, divided by N. So N was 12, the number of times it's compounded, and then raised to the 12. Again, notice there's another N right there, times T. So 12 times 5. Now what we're going to do is we're just going to go put that in our calculator. So I don't need to do any multiplying out, just copy it just like it is and put that in your calculator. So give that a try and see what you get for an answer. Okay, I'm going to put this up close so it doesn't have the glare on it, but you can see there's where I put mine in, and my answer came out to be 250509. So I'm going to write that down. So 250509 is how much is owed after those 5 years. All right, so now let's take a look at this next one. As a result of the Chernobyl nuclear accident, radioactive debris was carried through the atmosphere. One immediate concern was the impact that the debris had on the milk supply. The percent Y, so Y is here, of radioactive material in raw milk, so this is how much is in there, right? Y is the amount of radioactive material after T days is estimated by this formula right here. Estimate the expected percent of radioactive material in the milk after 30 days. So notice this has got that negative exponent, which is what's going to make this a reciprocal function right there. All right, so let's plug that in. So we're looking for Y, and then we're just going to do 100 times 2.7 raised to the negative 0.1 times, and then T is going to be 30 days because T represents the number of days, so times 30. So again, put that into your calculator and see what you get. Okay, so again, here I put it in my calculator, and there's my answer, 5.08. So since we're rounding it, we're going to round that off, so it's going to be about 5%, because remember, it's the percent. So that's going to be 5%. I don't think I'm going to drink that milk. All right, so we're done, and I'll see you in class next time.